You tap a button on your phone, and a world of colorful characters comes to life in a game. How does it happen? This feeling that technology is an unknowable, magical force is a powerful story we tell ourselves. We see the amazing result, but the process is completely hidden. This creates a deep mental conflict. We use these tools every single day, yet we feel completely disconnected from how they work, as if they were built by wizards. This view keeps us from exploring one of the most powerful ideas in the modern world. It makes us decide, without even realizing it, that understanding this is for someone else. But what if the secret inside that magic box wasn't magic at all? What if it was just a very simple, very obedient, and very literal follower of instructions? To understand programming, you first have to understand the mind of a computer. It is not intelligent. It has no creativity, no intuition, and no common sense. Its greatest strength is that it will do exactly what you tell it to, without question. Its greatest weakness is also that it will do exactly what you tell it to, without question. It cannot guess your intention. It cannot fill in the blanks. Our brains do this automatically, but a computer has no such ability. The psychological mistake we make is assuming the computer thinks like us. It doesn't. It thinks in a fundamentally simpler way. So how do we communicate with something so literal? We start with a single, clear command. Think about teaching a dog to fetch. You say fetch, you point, and the dog understands the command. It's a specific instruction with a predictable outcome. For a computer, a command is just a word that it is built to recognize. Words like add, draw, or move. Each command is a single tiny action. It is one drop in an ocean of possibility. But one drop alone doesn't create a wave. So the first step is realizing we can't just speak to it in broad concepts. We must use a limited vocabulary of actions it already knows. What happens when you want to achieve something complex, like displaying a photo on the screen? You can't just command it to show the photo. This is where the second key idea comes in. You need a recipe, a sequence of simple commands performed in a precise order. The plan is everything. The order of operations is critical. If you get the order wrong, the whole recipe fails. This is where our human minds often stumble. We see the big picture, but the computer only sees the very next step in the recipe. Let's imagine giving instructions to a robot to make a simple sandwich. Our human instinct is to say, make a peanut butter and jelly sandwich. But the robot, like a computer, would be frozen. It doesn't know what make means in this context. It doesn't know what a sandwich is. Walk to the cupboard. Step 2, open the cupboard door. Step 3, take out the bag of bread. You would continue this for dozens, maybe hundreds of steps. Get the knife. Unscrew the jar lid. Dip the knife in the jar. Each step is a tiny, undeniable action. This process of breaking a big, complex goal into the smallest, dumbest possible steps is the very soul of programming logic. It's a way of thinking that feels unnatural at first. Our brains are designed to take shortcuts and make assumptions. Programmer's brain has to be trained to do the opposite. It has to be trained to find every possible shortcut the mind could take and fill it in with an explicit instruction. You have to ask yourself, what am I assuming? And then turn that assumption into another line in the recipe. This is the part that feels intimidating. The part that makes us feel like programming is too hard. We feel a mental resistance to being so incredibly detailed because our daily conversations are never this precise. This brings us to the final piece of the puzzle, language. How do we actually write this recipe for the computer? We can't use English, French, or Spanish. These languages are beautiful, but they are full of ambiguity and double meanings. Consider the word run. It could mean to physically move, to operate a program, or even a tear in a piece of fabric. A human understands from context. A computer has no context. It needs a language where every single word has one, and only one, meaning. This is what a programming language is. Languages like Python, or JavaScript, or Java, are not like human languages at all. They are more like specialized toolkits. Each one is a collection of predefined commands and a strict set of rules for how to combine them into a recipe. The grammar rules of these languages are called syntax. If you get the syntax wrong, even by a single misplaced comma, the computer will stop. It won't try to guess what you meant. It will simply report an error, because the instruction is not in the exact format it was built to understand. Learning a programming language is less like learning to speak French and more like learning the rules to a very complex board game. So the real job of a programmer is not to be a brilliant wizard who creates things from nothing. The programmer is a translator and a planner. They listen to a human idea, a big, messy, wonderful concept. Then they painstakingly break that idea down into a logical, step-by-step recipe, accounting for every tiny detail. Finally, they translate that recipe from the language of human thought into a strict, unambiguous language that a computer can execute. The code you see on the screen is simply the final written form of that hyper-detailed recipe. The reason it looks so complex is because it has to be. It has to be a perfect, complete set of instructions for a machine that has no mind of its own. So here is the fundamental insight, the psychological shift you need to make to truly understand programming. Programming is not about math or genius or typing fast. It is the art of perfect explanation. It is the discipline of communicating an idea with such flawless clarity that even an inanimate object can understand it and act on it. When you realize this, you stop seeing a program as an intimidating wall of text. You start seeing it for what it is, a series of simple, logical thoughts. So how can you start practicing this way of thinking right now without writing a single line of code? You can start by narrating your world differently. Next time you do a simple task like making a cup of tea or tidying your room, pretend you are writing the instructions for a robot. Say each tiny step out loud. By practicing this total breakdown of a task, you are exercising the exact mental muscle a programmer uses every day. You are learning to see the hidden recipe in everything